we're talking about all of the quantum particles except for the hypothetical particles. Now, in the standard model, there's up, charm, top, down, and strange, and bottom. Quarks. Quarks are basically the things that make up protons and neutrons. So up and down quarks make protons and neutrons. And then all the other quarks are used for other things. So gluons are also used in the protons and neutrons, gluing together the quarks. Let's see how they make these particles, such as the proton and neutron. Well, the up has a 2/3 plus charge, but the down has a 1/3 minus charge. That means 2 downs and 1 up means it's a neutron, because the neutrons are neutral. Because 2/3 positive, 1/3 negative, 1/3 negative. A proton, there's like 2 up particles and 1 down particle. Because the up particles plus 2/3 plus 2/3 minus 1 equals 1 charge. Well, enough with the quarks. It's time to move on to the electrons. The electrons include the neutrinos, ranging in form of 3 main neutrinos: electron neutrino, muon neutrino, and tau neutrino. And then there's tau, muon, and electron. Neutrinos are basically little particles that travel very fast, almost the speed of light, through things. Trillions of them travel through our planet Earth without hitting a single atom.
中微子。
Yeah, neutrinos. Some people think that aliens are contacting us with neutrinos. We can detect them using large spaces. Okay, enough of the neutrinos, let's go on to the electrons. Electrons are the things that orbit the nuclei of atoms. The nuclei are like protons and neutrons stacked up together into a club. And then the electron orbits it. No, not exactly orbits, because instead of orbits, it is in the electron shell. Well, that shell's imaginary. We are showing you the shell because the electron can only move in the shell. It teleports everywhere. In your standard book, you might see the thing like there's like proton, neutron, center, and then an electron orbiting it. But that isn't how it goes. It doesn't orbit it, so it's all completely random. Okay. The electron also has a -1 charge, so from the atom, because the protons are +1. But you need the amount of protons and the electrons to be equal, also to create an imbalance.
要不就带电了。
Yeah, and then that's actually how they make the electricity flow. You know how the copper are very conductive because the electrons can move on through very quickly.
我知道。还有一些就是你搓头发吗？
Yeah.
就会静电吗？ 是不是把那个电子给
It's
搓
called
掉了
static electricity.
OK， 是不是把那个电子搓掉了？
And then there's muon and tau. Muon and tau are like heavy, are like versions of the electron, but heavier, lots times heavier, and very, very, very unstable.
很不稳定吗？
Yeah, it's unstable. And then there's the gauge boson, also known as the force-carrying particles. There's the photon, gluon, Z boson, or W boson. First, the photon carries the electromagnetic force. The electromagnetic force is like electronics and magnetics, but you combine together. In nature, electronics and magnetics combine very easily.
电磁场。
Yeah, and electricity. So with electricity, you can make magnetic. With magnetic, you can make electricity.
OK。
So like they're interconnected. Then the gluon, which is responsible for the strong nuclear force. It is also the thing that binds together particles and is creating an immense forces.
所以叫 gluon.
And they're very, very unstable.
也不 stable.
But it's stable in atoms, so you don't have to worry about yourself falling apart. And then there's the W and Z bosons. They are both responsible for the nuclear weak force. They're responsible for some nuclear decay.
什么东西？
Some nuclear decay.
什么东西 responsible for that?
The W and Z boson, which is responsible for weak nuclear force, and nuclear decay.
Okay.
Nuclear decay is where where huge particles start to decay because they're unstable.
Oh,
Like Einsteinium,
okay.
fermion.
Fermion, 费米子。
Yeah, Fermi paradox. Okay, that's pretty much it. But there's more to it. There's even hypothetical particles. But we'll move on that in another chapter.
Oh, thank you. Bye.
Thank you.